Frontier AI Research Digest, The Agent Training Revolution. Upbeat tech intro music. Host on screen, casual but engaged. Host ***. For the last year, there's been a frustrating gap in AI. We've got these incredibly powerful agent systems, Claude Code, Codex, OpenClaw, that can browse the web, write code, use tools. But training them? That's been nearly impossible. The training infrastructure just didn't exist. This week, that changed. Graphic, OpenForgeRL with agent training pipeline animation. Host ***. A paper called OpenForgeRL from Microsoft Research basically solved the infrastructure problem. They built a system where a lightweight proxy sits between the agent and the model, records everything as training data, and feeds it into a standard RL pipeline. The results are impressive. Their trained agents match or beat models several times larger on browser tasks and coding benchmarks. But here's the really interesting part. When they analyzed what RL actually improves, they found something surprising. Graphic, split screen, what RL improves vs what RL doesn't improve. Host ***. RL makes agents better at self-verification. Better at using tools. Better at completing multi-step plans. But critical abilities like error recovery? Still weak. The agent can follow a plan, but if something goes wrong, it still can't recover. That's a fundamental limitation of current training approaches. Graphic, AREX with recursive loop animation. Host ***. Then there's AREX, a recursively self-improving agent for deep research. Instead of just searching longer, RX alternates between gathering evidence and auditing its own answers. It compresses its own history into a compact state, so it doesn't drown in context. A 4 billion parameter model using this approach competes with models using far more parameters. That's not just efficient, that's a different paradigm. Graphic, PATs with scaffold animation. Host ***. And PATs showed that the way we train agents matters enormously. Instead of treating skills as fixed modules, PATs creates dynamic evidence cards from each training run and adjusts the training context adaptively. As the policy improves, redundant context gets pruned. The result? Up to 18% improvement while using 32% fewer tokens. Graphic, warning sign, no universal harness. Host ***. But here's the sobering reality check. A massive study this week tested 30 different agent harnesses across 12 model problem pairs using over 3 million LLM rollouts. The conclusion? No single harness is universally superior. The best harness for one problem is mediocre for another. Harness choice is a hyperparameter, not a universal recipe. Host back on screen. Host ***. So what does this mean? The agent training infrastructure is finally being built. We can now train agents end-to-end. But the field is discovering that the problem is harder than expected. Harnesses don't generalize. Error recovery remains weak. And the training process itself needs to be adaptive. The next frontier isn't better models.